1 is equal to 2. How?
You're going to prove?
Yes. Let A equal B. A is equal to B.
Okay.
Then multiply both sides by B to get AB is equal to B squared. Now subtract A squared from both sides. On the left side we get AB minus A squared and on the right side we get B squared minus A squared. How I got B squared? Because I multiplied both sides by B. So on the left I got AB and on the right I got B squared again.
Okay.
So on the left we know that the distributive property, we know that exponents are repeated multiplication. So it will write it as like AB as like this. AB minus AA. So they both have a common factor of A. So we just factor out that A into a single factor has been multiplied by the whole root B minus A. And on the right side, remember a mathematical identity that B squared minus A squared equals B plus A times B minus A. Don't know it? Let's see. 8 times 8 equals 64. 7 times 9 equals 63. 8 minus 1 is 7. 8 plus 1 is 9.
Okay, then?
Then we get the difference between 64 and 63 is 1 square or 1. Similarly, 6 times 10, 8 minus 2 times 8 plus 2 is 60. The difference between 64 and 60 is 2 squared or 2 or 4. So that's how it works. So when I take 8 plus A times 8 minus A, you get 8 squared, you get 64 minus A squared in the new equation. Let's replace 8 with B and you get B plus A times B minus A equals B squared minus A squared. Now the right side of our equation was B squared minus A squared. So we substitute B plus A times B minus A there, and then both these sides have a common factor of B minus A or 0. So both these sides equal 0 because B minus A is 0 because A equals B and A minus A. So we can substitute B with A and we get A minus A which is also 0. And anything multiplied by 0 is just 0. So both these sides equal 0. But then we can divide both these sides by B minus A. But since B is equal to A and A minus A is 0, we are breaking mathematics at this point. We are eventually dividing by 0, which can be done, right? But let's just carry on. And we get A is equal to B plus A. Then we divide both sides by B minus A. And since A is equal to B, then just say A is equal to A plus A. Substitute 1 in this new equation. Substitute A equals 1 in this new equation. And then that means that B is also 1. And you get 1 equals 1 plus 1. Therefore 1 equals 2. And you can extend it to other properties, like if you had A equals 8 rather than 1 and then B equals 8, and you get the equation 8 equals 16. That's faulty because we tried to divide by B minus A, right? And B was the same as A. So we'll substitute B with A and you get A minus A, which is 0. But at that point we broke mathematics again. We eventually tried to divide by 0. But can we do that? No, we can't. That was a nice contradiction. But a simpler way to do that is to say that A times 0 equals 2. That 1 times 0 equals 2 times 0. Because anything times 0 is 0. Now when we divide by 0, we get 1 is equal to 2 again.
Very good.
So it can also say that A is equal to 2A. Because if I take A is equal to 32, we get the faulty equation 32 equals 64 at the end.